Given points P, 0, 0, Q, 2, 4, and R, 6, 0, determine the equation of the circle passing through P, Q, and R.
To determine the equation of a circle, we need to know the center of the circle, and the length of the radius.
PQ, QR, and PR are clearly chords of the circle, but even though the diagram is not drawn to scale, it should be obvious that neither of these chords pass through the center of the circle, which means we do not have a diameter, and therefore we cannot determine the center of the circle, nor the radius.
Recall from Euclidean geometry, that a line passing through the center of a circle, perpendicular to a chord, bisects that chord. This is important information, because the intersection of the perpendicular bisectors of two chords of the circle, gives the center of the circle. In other words, the perpendicular bisector of chord PQ, and the perpendicular bisector of chord QR, will meet at the center of the circle. This is also true for the perpendicular bisector of chord PR. So, if we can determine the equation of these perpendicular bisectors, then we will achieve the first objective of determining the center of the circle. On a side note, a triangle whose vertices lie on the circumference of a circle is said to be circumscribed. Another way of saying this is, if a circle passes through the vertices of a triangle, the triangle is said to be a circumscribed triangle. The point at which the perpendicular bisectors of the sides of the circumscribed triangle meet is called the circumcenter. To determine the center of the circle, we will only need to determine the equation of two of these perpendicular bisectors. The perpendicular bisector of a line segment is another line segment that cuts the first line segment at 90 degrees, and in half. So, the perpendicular bisector of chord PQ, which is MA, cuts PQ at 90 degrees, and it also cuts PQ in half. In other words, A is the midpoint of chord PQ. Similarly, MB is the perpendicular bisector of chord QR, and MC is the perpendicular bisector of chord PR. To find the equation of a straight line, we need to know the gradient of the line, and one point that lies on it. In other words, to find the equation of MA, we need to know a point that lies on the line, and we also need to know the gradient of the line. The point we will need is point A, which is the midpoint of chord PQ. So, we use the midpoint formula to do so. A is therefore the point, 1, 2. We know a point that lies on line MA, we now need to know the gradient of the line. Since MA is perpendicular to PQ, we will first determine the gradient of PQ. The gradient of PQ is 2, which means that the gradient of MA is minus a half, since the product of the gradients of two perpendicular lines is minus 1. And now that we have a point that lies on MA, and we know the gradient of MA, we can determine the equation of the line. The equation of MA is therefore, y equals minus a half x, plus 5 over 2. If you are unsure about anything we have just done, or just want to refresh your memory, these concepts are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. We proceed in a similar manner to determine the equation of MB. B is the midpoint of chord QR, so the coordinates of B are 4, 2. The gradient of QR is minus 1, which means that the gradient of MB is 1. The equation of line MB is therefore, y equals x minus 2. And now that we know the equation of MA and MB, which are the perpendicular bisectors of PQ and QR respectively, we can equate the two equations, which will give us the coordinates of the center of the circle. The center of the circle is therefore the point, M, 3, 1. The last thing we need to do is to determine the radius of the circle.
We know 3 points that lie on the circumference of the circle, P, Q, and R, and we have just determined the coordinates of the center of the circle, so finding the radius of the circle is pretty straightforward, using the distance formula.
MP, MQ, and MR are all radii of the circle, and are therefore all equal, so it doesn't matter which of the 3 points you use. The radius of the circle is root 10 units. And now that we know both the center and the radius of the circle, we can determine the equation of the circle, which is given by x minus 3, all squared, plus y minus 1 all squared, equals 10. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.